Hey, I wanted to cover another optimization technique. So we have these stat counters which time scopes for us, and we can identify where things are taking a long time in insights and try and make those functions faster. But that is not always the case. Like, you can't always just make a function faster. Maybe you've got it about as fast as you can go. And there's another type of problem that arises, and that is having the function being called too many times or redundantly. So here in the tick function, I have this expensive function called getValue or cached, and it's being called many times. And so one optimization is, if we know we don't need this many times, we could just delete all these functions out and only call it once. Now, in the real world, that's generally more complex than this, but you might have this nested multiple times in a given function. So the question is, how do you identify that? And so the stat counters can actually help you identify that in the insights view. One fix is to just simply remove the extra function calls. So while deleting these extra function calls is probably the ideal solution, sometimes you're not able to do that for other reasons. Like if it's many external systems calling into this, you can't really easily refactor those or quickly do it. And so another approach is to actually cache the expensive part of it and return that. And so this function also does that we can turn on via cvar. Notice this is a const function, and these variables here are mutable so that we can change them and cache them. I'd say this is a kind of precarious or dangerous solution, so try to avoid using caching when you can. But we'll get into that in a moment and see how to identify these problems in insights. So I have this actor here with the instructions of what to do. So we need to enable stat named events on the pie. So we'll do stat named events. So that turns on our scopes, and then change our cvar to, we're going to disable it first, so there's no caching, and we'll take an insights capture. So to do that, I'll go down here and I'll just start collecting, and we'll wait a little bit, and then I'll stop collecting. And now I will open up the insights session viewer, and there's the new one. And so I go back to the code generally, and I'll just copy the prefix of my stats, so these are easily searchable. I'll go back to the session viewer, and I'll rename that disabled video, which is the one I recorded. And then we'll go in here, I will re-enable the caching, and then I will start collecting. And then I'll stop collecting. Then in the session view, we will rename that new one to our stat name enabled video. And so we can open that up, and we'll search our timer for our prefix. And this was the top level stat. So if I hop back over to the code, this one is the top level for the function, and then the function either caches or it doesn't cache. And so we'll highlight that, zoom out, zoom into the spot where they are. Alright, and there we can see them being called multiple times. And below this, we can see that the calculating is the one that's being called. So highlight event, it's calculating each time. It's not using the cached. If it were using the cached, we'd see using cached value, but we're seeing calculating cached value test. So what we can do actually is highlight a region. So with these, what we can now do is highlight a region using this top bar up here. And with a region highlighted, over here it reflects the number of calls that we see. So if I highlight that, you can see it only shows 8. Here it only shows 7. So you can see 1, 2, 3, 4, 5, 6, 7. Got 3 highlighted there, 3. And so what this means is you can find your frame. So frame here, and we can highlight the frame, and we can get an idea of how many times a function is called. And so if you have a thing that you're particularly worried about, you might identify that it's like called all over the frame, and maybe you can reduce some of those, or maybe you have to cache. And so let's look at what happened when I cached. So if we open up the caching enabled, let me paste the stat. So if we highlight the top one and find some of those, we can see here that we have one calculating cached value test, and then we have multiple smaller using cached value scopes. So these are pretty quick versus the calculating value test that only does one. And so how that caching works. So if we look at the actor, we have a cached frame. So this is a frame counter, and we have a cached value. And so in our tick, we have this get value or cached, and I'll just drop a breakpoint right there, and we can step through it. All right. And so we are in our tick function, and it currently set the frame counter to the current frame counter. This is a global variable that you can use. It is a steadily increasing frame counter, and prefer frame counter over something like frame number, because frame number is associated with rendering, and if you have a dedicated server, you're not rendering. Anyways, if we step into this, get value or cached, it's going to test that our cached frame, which is that, is equal to our current frame, which it is not since it's the first time the function is called. And we set up our scope counter, get our world, and this is just some nonsense math. It's effectively calculating a transform based off the time and then doing a bunch of like inverse transform stuff and multiplying the transforms together, just trying to waste time really. And so once it's done, I use x value as our important value for whatever reason, and I cache that. And then I cache the current GFrameCounter. Now we return the cached value, and the next time this function is called, goes into here, and it checks is the frame counter the same, and it is, so it uses the cache value instead of recalculating it. Now there are some really important ways you can mess up with this, and one of those is that when pieing, these global variables are effectively shared between the server and client because they're not associated with the actor itself. And so that's why I cache on the actual actor rather than this test output. It's going to be effectively shared. And I show that here. So I have this shared pie value between tests. And if we look down here, we have dedicated server. So we're currently executing on the dedicated server. So the dedicated server just cached 16773, and I'm going to continue until we hit the client here. Now on the client, you can see that we are still 16773. And this is how sometimes Pi can share values between the same process. And just to make sure that point is clear, if we resume to the dedicated server, we can see the value is 17093. We overwrite that to 17094. And if I continue, now we are on the client and the value is 17094. So it's already been updated. So if you were to cache something in a global variable, the client would be caching what the server has, and then your tests are going to be flawed and you might not realize it immediately and have to debug what's going on. And that's generally why global variables might not be the best option when testing in Pi. This would probably work in a actual standalone, but because of that reason, I think it's important to just do your caching as member variables on the actual actor itself, which will be its own instance in memory. For the server and the client, it'll actually do proper replication between the two. But in general, like when you do caching like this, you can end up in cases where maybe it caches too early also. It's generally problematic to cache like this, so I would use it as a last resort, and if you can, try to find places you can just remove the functions as opposed to caching. But caching is an option if you end up needing it. And just to finish this video up, I'm going to run through the code real quick. So we have our actor here, which is frame caching test actor. Has its constructor, which just enables the tick. It has a begin play, which is doing nothing at the moment. It has a tick, which is where we have all the redundant function calls, and some tests to show that values are shared. It has a function get value or cache, which either returns a cached value or calculates that value and then returns the cached value. The important note is that it is a const function, and it is able to cache the values nonetheless because these are flagged as immutable. And some people do take problem with using the mutable keyword. It is kind of violating your constness. But it is useful for situations like this where it's really not supposed to change the state of the object. We're just trying to get around it. And that's it for that. We have quick scope cycles to profile this. And I did a regular stat here, which is just defined up here, declare cycle stat. And had to declare group to define it this way. And here's the cvar. So enable frame caching tests by default is false. And the cvar sets it up here. cvar.enable frame caching test, and we have this volatile float, which is test output. Is really not important for the tests here. And we have this other volatile uint64 to show how Pi can sometimes share values and why it's a good idea to cache actually as member variables if possible. So I hope that helps, showing you another way to use insights to identify problems in your code and make decisions about how to optimize those and give you some potential options if there are no easy way to reduce the number of function calls. Let me know if you have any comments, questions, or concerns, comment below. And if you think this would help someone, then please share the video. And until next time.